Okay, so let's start off with a simple series and a simple parallel circuit combination. So we've got three resistors, 10, 15, and 20 ohms connected in series across a 5-volt battery. And I want to find the total resistance, the current through each resistor, and the voltage across each resistor. So let's start off by drawing a picture. So I've got three resistors in series, so that looks like that, one right after the other. And they're hooked up across the battery. So I'll draw it like this. Remember, the long side is positive and the short side is negative. So current comes out of the battery and it's going to go around from the positive through each of these resistors, and there's nowhere where the current can split up. So when they're in series, I is the same and V is different. And what is V going to be through each resistor? Well, V is given by Ohm's law, V equals IR. So since I is the same for all of them, V1 is just going to be I times R1. The voltage across resistor 2 is going to be I times R2. And the voltage across resistor 3 is I times R3. So what I have to do here is I have to find the total resistance, use that to give me the current by the fact that the voltage from the battery is going to be equal to the current times R total, or R equivalent. Okay, so if I've got V battery, if I can find my R total, then I can solve for my current, and then once I know my current, I can go through and get the voltages. So let's call these, so we've got the 10 ohm resistor, let's call that R1, the 20 ohm resistor, let's call that R2, and the 15 ohm resistor, let's call that R2. And the 20 ohm resistor, let's call that one R3, just so we know what we're talking about. All right, so what's the rule? The rule for R total in series is just that R total is equal to R1 plus R2 plus R3. So R total is equal to 10 plus 15 plus 20, which is 45 ohms. So R total is 45 ohms. Now I know my R total. So now I know my V bat, I know my R total, I can find the current. So my equivalent circuit, if I redraw that, is just, I've got the battery, 5-volt battery, and a 45 ohm resistor. And so I can find my current. I is equal to the voltage from the battery over the total resistance. So that's going to be 5 over 45, which is 0.111 repeating amps. And that's going to be the same for all the resistors. Okay, so I1, I2, and I3, they're all the same. They're all going to be 0.1 repeating amps. All right, so now I can find the voltage on each resistor. V1 is equal to I times R1. So it's going to be equal to 0.111 times 10. So it's going to be 1.11 volts. V2 is going to be I times R2. So it's going to be 0.111 times 15, which is 1.67 volts. And V3 is going to be I times R3. So it's going to be 0.111 times 20, which is 2.22 volts. Okay, and to check my answers, I know that the sum of the voltages, V1 plus V2 plus V3, has to be equal to the voltage across the battery. So I can check. If I do 1.11 plus 1.67 plus 2.22, I get 5. All right, so I can double check my answer. It all works out. Okay, so let's do the same problem, but now we're going to have those same three resistors connected in parallel across the battery. Okay, so now if I draw my circuit, my original circuit's going to look like this. So I've got my 5-volt battery, and now I've got the three resistors connected in parallel. Okay, forgive my drawing here. Let's see, that should all look together. All right, so I've got 5 volts, I got 10 ohms, 15 ohms, and 20 ohms. And let's again call those R1, R2, R3. Okay, so we want to do the same thing. Find the total resistance, the current through each resistor, and the voltage across each resistor. So now in this case, we have a current that comes out of the 5-volt battery, and when it gets to this point here, there's a junction. So part of the current is going to go down through R1. We'll call that I1. The rest of the current is going to carry along till it hits the next junction. Then it's going to split up again. Part of it's going to go through resistor 2. We'll call it I2. Part of it's going to go through resistor 3. We'll call that I3. And then they'll come back and join all together, and we'll get back to the same total I going back into the negative terminal of the battery. Okay, so what we know is when they're in parallel, V is the same, and it's going to be equal to the voltage across the battery in this case, because each of these resistors is hooked up just from the top of the battery to the bottom of the battery. So V is 5 volts for all of them. So we've answered the third part already. What's the current? Well, we know that Ohm's law has to be obeyed. It's V equals IR. So I know that I1 is going to be equal to V, the 5 volts, over R1. I2 is going to be V over R2. And I3 is going to be equal to V over R3, where V is equal to 5. Okay, so I can find those straight away. So I1 is equal to 5 over 10, which is 0.5 amps. I2 is equal to 5 over 15, so that's a third, so 0.33 repeating amps. And I3 is going to be equal to 5 over 20, which is 0.25 amps. Okay, great. So I answered, and I'm going in reverse this time with my answer. And I've got the voltage, I got the current. I want to find the equivalent resistance, the total resistance. And what we know is for resistors in parallel, we add the inverses and then we take the inverse. So I'm going to do 1 over R1 plus 1 over R2 plus 1 over R3. And then I'm going to take 1 over my answer. So I'm going to do 1 over 10 plus 1 over 15 plus 1 over 20. And whenever I do this adding the inverses, remember, take the inverse at the end. That's the biggest mistake that students make sometimes on the test. So if I do that, the thing in brackets comes out to 0.217 on my calculator, and then I'm going to take 1 over that, and I get 4.62 ohms. So when you add things in parallel, the answer should always be smaller than the smallest one. So it should be smaller than 10, and that's what I got. So if I look at my circuit here, now my equivalent circuit is a 5-volt battery with a 4.62 ohm resistor. And so the current, the total current through that circuit should be equal to V over R total, battery voltage over R total, just like we did for the other equivalent circuit. So 5 over 4.62, which is 1.08 amps. And I can go back and I can double check my answer to make sure I got it right. If I got it right, I1 plus I2 plus I3 should be equal to I total. Okay, so if I do that, I've got 0.5 plus 0.33 plus 0.25, and if I add that up, I get 1.08. All right, so I double checked. Those two are the same as each other. Okay, so now we're ready to do some circuits where we've got a bunch of different combinations of resistors. Okay, so guys, I'm just trying to get this thing to stop recording.